Hello everyone! Pag-usapan natin ang derivative of exponential function involving the mathematical constant, the Euler's number e. Isa ito sa pinakamadali na formula when it comes to getting the derivative kasi kapag kukuhanin natin ang derivative with respect to x ng e raised to x, it is simply the same e raised to x. So walang nagbago sa kanya. Kaya madali siyang kuhanan ng derivative. That is why in solving its derivative, merong ibang formula na involved, kadalasan ang chain rule of differentiation. Kaya i-recall din natin siya. If we are getting the derivative of y with respect to x, ang gagawin lang natin, kukuhanin natin yung derivative ng y with respect to u. This is our outer function. Kukuha tayo ng certain u na part ng y, tapos imumultiply natin siya dun sa derivative nung kinuha natin na u with respect to x naman. Pero of course, hindi lang tayo limited dito. If we want to expand yung paggamit ng chain rule, pwede pa naman as we introduce other variables kung kailangan dun sa kinukuhanan natin ng derivative. So now, let us start with our first example. We have y is equal to e raised to 3x. Again, alalahanin natin na ang derivative ng e raised to x ay pareho lang na e raised to x. Walang magbabago sa kanya. Kaso ang problema natin, kumukuha tayo ng derivative ng e raised to 3x. Kaya kailangan muna natin siyang gawa ng paraan. Applying chain rule, kuhanin natin yung exponent, tapos ile-let natin siya as u. To do that, we let u be equal to our exponent 3x. Kaya ang mangyayari, yung given natin na y is equal to 3x, mapapalitan to ng u. This will become y is equal to, ang 3x ay naging u, so this is e raised to u. Ngayon, pwede na tayong kumuha ng derivative. Applying our chain rule of differentiation, sulat lang natin, if we are getting the derivative of y with respect to x, this is equal to, kuhanin natin yung derivative with respect to u nung y that is already equal to e raised to u. Ipapalit lang natin to dun sa y, so derivative with respect to u ng e raised to u, tapos imumultiply natin siya dun sa derivative naman ng kinuha natin na u that is already 3x with respect to x. So we have derivative with respect to x of our u that is 3x. Pwede na natin siyang gawin. According to our formula, ang derivative ng e raised to x is just equal to e raised to x. Ganun yung mangyayari dito. Since we are getting the derivative with respect to u, wala ring magbabago sa kanya. Kaya dito, this will still be e raised to u. Tapos imumultiply natin siya sa derivative ng 3x with respect to x. Applying power rule of differentiation, kuhanin lang natin si 3. Tapos, ang derivative ng x with respect to x is just equal to 1. So, we have 3 times 1. And then, as we multiply, this is equal to 3 times 1 is 3 times e raised to u. We have 3 e raised to u. Tapos, ibabalik lang natin siya with respect to x. Ang u natin is equal to 3x. So, our dy over dx, the derivative of y with respect to x is already equal to 3e. Our u is equal to 3x. So, this is 3e raised to 3x, this is our final answer. Applying chain rule of differentiation. Madali na siya kapag nakakuha tayo ng derivative ng e raised to x, or in our case, e raised to u with respect to u, kasi wala namang nagbabago sa kanya. Ang medyo komplikado lang dito ay yung paggamit natin ng chain rule. So with that, we can proceed with our second example. We are given with y is equal to e raised to x squared minus 3x plus 1. Medyo marami na yung nasa exponent ni e. But still, we apply the same process. Para makuha natin yung derivative, we let u, yung nasa exponent, para masimplify natin to. So, we let u be equal to x squared minus 3x plus 1. Kaya ang mangyayari, etong buong part na to ay mapapalitan ng u. So, our y will become e. This part will become u, so e raised to u. Now, we will be getting its derivative by applying chain rule of differentiation. Again, ang chain rule natin, the derivative of y with respect to x is just equal to, kuhanin muna yung derivative ng y with respect to u, tapos imumultiply siya dun sa derivative nung nilet natin as u, which is x squared minus 3x plus 1. So, kuhanin natin yung u, tapos kuhanin yung derivative with respect to x. Now, we can apply our differentiation, the derivative of y with respect to u, so this is equal to derivative, ang y is just equal to e raised to u. Walang magbabago dito, madali na to. And then, imumultiply lang natin siya sa derivative with respect to x nung u. that is x squared minus 3x plus 1. Then kuha tayo ng derivative, e raised to u with respect to u, applying our formula para sa derivative of e, wala namang magbabago sa kanya, so this is equal to e raised to u. Tapos imumultiply siya sa derivative ng x squared minus 3x plus 1. Since they are separated by subtraction and addition, pwede natin kuhanin yung derivative nila na magkakahiwalay. Again, as we recall our power rule of differentiation, kapag kukuha tayo ng derivative with respect to x ng x raised to n, ang gagawin lang, ibababa si exponent, tapos i-multiply kay x, tapos yung exponent na n ay bawasan ng isa. Ganun yung gagawin natin dito. So, ibababa natin yung exponent ni x squared, that is 2, applying power rule, bringing down 2, imumultiply kay x, tapos yung exponent na 2 ay bawasan ng isa. So, you have 2 minus 1 or simply 1. This will become x raised to 1 or simply equal to x. Tapos, punta tayo sa susunod na term. Gamitin natin yung same operation. We have minus, kuhanin si 3. Ang derivative ng x with respect to x applying power rule, kasi meron tong exponent na 1 is just equal to 1. So, we have 3 times 1. And then, for our 1 here, ang derivative ng constant is just equal to 0, any constant. Kaya since 1, constant naman siya, ang derivative niya is equal to 0. Now, we were able to get the derivative ng x squared minus 3x plus 1. Simplify na lang natin to. So, we have e raised to u. Tapos, naka-multiply. We have 2x minus 3 times 1 is 3 plus 0, kaya walang magbabago. So, we have 2x minus 3. And then, ibalik na lang natin yung u with respect to x. As we look above, ang u, we let this be equal to x squared minus 3x plus 1. Then, pagpalitin lang natin, ayusin natin yung grouping symbol. Our dy over dx, this is just equal to, ang u is x squared minus 3x plus 1. So, sulat natin siya. This is e raised to x squared minus 3x plus 1. Tapos, nakamultiply tayo kay 2x minus 3. So, this is the process para makuha natin yung derivative nung given natin na y is equal to e raised to x squared minus 3x plus 1. This is our final answer. Pero if you want to rearrange the terms para mas maging presentable yung sagot, pwede mo rin siyang gawin as dy over dx. Pagpalitin lang natin yung unahin si 2x minus 3. We have 2x minus 3 multiplied to e raised to x squared minus 3x plus 1. Any of the two can be your final answer. With this, we are done with our example number 2. Punta na tayo sa ating pangatlong example para sa derivative ng exponential function involving e. So, we have y is equal to e raised to 2x cubed plus 1 cubed. Medyo may problema tayo kasi we have e, ang exponent niya is 2x cubed plus 1, tapos meron pa tayong exponent na 3. Kaya gagamit tayo dito ng chain rule of differentiation twice. Kasi kung titignan natin, if we let u be our exponent, 2x cubed plus 1, and then cube, alalahanin natin na kukuhanin din natin yung derivative na to. Kaso nga lang, meron tayong function sa loob nung exponent na 3. Kaya kailangan pa rin natin gumawa ng isa pang chain rule. Para mas maging organized yung solution natin, hayaan natin yung inner function. If you can get the derivative directly, okay lang naman. Pero as we take the process step by step, we can let v be equal to dun sa nasa loob para hindi tayo mahirapan. So we have v is equal to 2x cubed plus 1, yung nasa loob. Kasi if we do our substitution, yung y magiging e raised to etong buong to, we let this be equal to u. So we have e raised to u. Ngayon, gagamit na tayo ng chain rule of differentiation. So una, to get the derivative of y with respect to x, yung given na y, kuhanin muna natin yung derivative niya with respect to u. Kasi this is e raised to u. So we get the derivative with respect to u. Kaso nga lang, kailangan din natin kuhanin yung derivative ng u. Meron pa tayong 2x cubed plus 1 raised to 3. Medyo mahihirapan tayo dito. That is why I would suggest kaya natin ginawa to is ipapalit natin si 2x cubed plus 1 dito sa nasa loob. Kaya ang u natin will become, substituting 2x cubed plus 1 as v, this will become v cubed. Kaya kuhanin muna natin yung derivative ng u with respect to v, tapos isa pang multiplication, kuhanin naman natin yung derivative ng v, kasi ang v na lang natin is equal to 2x cubed plus 1. We can get its derivative with respect to x. Ngayon, naging 3 na yung terms natin. This is by applying chain rule of differentiation ng 2 beses. Medyo matrabaho lang siyang iset up, pero kapag natapos na natin siya, we can just focus on getting the derivative. Kasi this is equal to, kuhanin natin one at a time, derivative with respect to u, nung y, our y is equal to e raised to u. Madali na yan. Kasi e raised to u lang naman siya. Tapos, imumultiply naman natin sa derivative with respect to v nung u, that is equal to v raised to 3. Pwede natin itong kuhanin via power rule. Tapos, lastly, imumultiply naman natin sa derivative ng v, that is 2x cubed plus 1. So, derivative with respect to x nung 2x cubed plus 1. Medyo humaba siya, pero mas madali na siyang kuhanan ng derivative kasi puro power rule na lang ang gagamitin natin. So now, continuing with our process, this is equal to, ang derivative ng e raised to u with respect to u, walang magbabago, this is still e raised to u. Tapos, imumultiply siya sa derivative ng v cubed. Power rule lang, ibababa si 3, tapos times v, tapos yung exponent ng 3 ay bawasan ng isa, 3 minus 1, this will become 3v squared. Tapos, yung sagot ay imumultiply sa derivative ng 2x cubed plus 1. Power rule lang din, pull out si 2. Tapos, ang derivative ng x cubed, ibababa sa exponent. So, this is 2 times 3 times x. Tapos, yung exponent na 3 ay bawasan ng isa. 3 minus 1 is 2. Plus, derivative of a constant. Ang 1 ay constant lang naman. So, this is equal to 0. Now, we simplify. So, this is equal to, sulat ko na lang dito yung sagot para may reference tayo. Sa kabila, talon tayo dito. So, this is equal to e raised to u multiplied to, we have 3v squared. And then multiplied to, 2 times 3 is 6 times x squared. So, this is 6x squared plus 0. This is still 6x squared. Ngayon, ibalik na natin yung variables in terms of x. As we recall, yung u, that is equal to 2x cubed plus 1 cubed. So, this is just equal to, ibalik natin our e raised to u, that is 2x cubed plus 1 and then cube. Okay? So, wala naman nangyari dito. Madali lang siya. Nanggaling tayo dito. And then, we have our 3v squared. As we remember, our v is equal to 2x cubed plus 1. Kaya this is multiplied to 3 times our v is 2x cubed plus 1. Huwag nating kalimutan that this is raised to 2. So, this is squared. And then, this is multiplied to, as we follow, we have 6x squared here. So, multiplied to 6 and then x squared. Then, tignan natin kung ano pa yung pwedeng i-multiply. You can expand this one if you want, pero sa akin, pwede na namang iwan siya as is. Then, we can multiply 3 times 6, that is 18. Pagsamahin natin to, tapos ilagay natin sa unahan. So, we have equal to 18. Isama na natin si x squared. 18x squared. Ito yung minultiply natin. So, ilagay natin yung susunod times, we have 2x cubed plus 1 and then squared. Tapos, nakamultiply din tayo. So, ayusin ko na lang yung grouping symbol para mas madali siyang tignan. We have e raised to 2x cubed plus 1. This is raised to 3. Now, this is our derivative. This is our final answer. Ito yung dy over dx. As you can see, madali lang naman kuhanin yung derivative ng e raised to u. Ang medyo naging komplikado lang ay yung paggamit natin ng chain rule, in this case, 2 beses. So, this is it for our example number 3. Now, let us proceed with our last example for this lecture video. This is our example number 4. We have y is equal to e raised to 3x squared over e raised to x squared minus 4. As we can see, meron tayong term sa numerator tsaka denominator. If you are familiar with the quotient rule of differentiation, medyo tempting na gamitan siya ng quotient rule, although makukuha siya, kaso the solution will be longer. Kaya what I would like to suggest is pwede tayong gumamit ng loss of exponent. Kasi as we can see here, yung term na nasa numerator, yung base is e, yung base na nasa denominator is also e. Kapag we are performing division with the same base, for example, if we are given with x raised to a over x raised to b, this is just equal to kuhanin yung base, tapos kuhanin yung difference ng terms. Yung nasa numerator minus yung nasa denominator. Ganun yung gagawin natin sa kanya. Rewriting, tong terms na nandito, usod ko lang para hindi tumama doon. So you have y is equal to e. They share the same base. Tapos kuhanin yung nasa numerator, that is 3x squared, minus yung exponent ng e na nasa denominator. So this is minus, wag kalimutan si grouping symbol kasi nagsusubtract tayo sa buo, minus x squared minus 4. Then we perform the operation first. This is equal to e 3x squared, kopyahin. Tapos ayusin muna, since we are performing subtraction, this will become minus x squared. Tapos yung minus 4 will become plus 4. Kasi nasa labas yung subtraction, kailangan baguhin yung operation nung nasa loob. Then this can be still simplified as e raised to 3x squared minus x squared is 2x squared plus 4. Madali na siyang gawaan ng chain rule. We let u be equal to the exponent 2x squared plus 4. Then applying chain rule of differentiation, we have dy over dx is equal to derivative ng y, una, with respect to u muna, tapos imumultiply siya sa derivative ng u. Already, pwede na natin kuhanan ng derivative with respect to x. So this is just equal to derivative with respect to u ng y. As we can see, ang y is e raised to x squared plus 4. So by the way, nilat nga pala natin yung exponent as u. So we have our y here. Ang bagong value na niya is e raised to 2x squared plus 4, that is u. So this is e raised to u. So derivative of y or derivative of e raised to u, and then multiplied to the derivative with respect to x, our u is already equal to 2x squared plus 4. Then we can get our derivatives. So this is just equal to, ang derivative ng e raised to u is itself, so this is still e raised to u, multiplied to, applying power rule, ihiwalay si 2, tapos ibababa sa exponent, so this is 2 times 2, tapos x, and then bawasan ng isa yung exponent, so this is 2 minus 1, we can write this as x raised to 1 or simply x, and then plus, derivative of a constant is just 0, then we simplify, this is equal to e raised to u, multiplied to 2 times 2 is 4, times x is 4x, plus 0 is still 4x. Then our u is equal to 2x squared plus 4. Pagpalitin ko lang, unahin ko si 4x. We have our dy over dx. Isulat na natin siya dito. That is equal to, unahin si 4x, and then multiplied to e. Our u is equal to 2x squared plus 4. So this is raised to 2x squared plus 4. This is the derivative of our given function. So with this, we were able to solve problems involving exponential functions na merong e or Euler's number. As I have said earlier, yung chain rule lang yung medyo nagpapahirap sa kanya, pero kaya naman siyang gawin. With this, I hope that you have learned something on this lecture video. See you on the next one.